Hi there. All right, working with integers is a key part of any sort of algebra class, and so this is an important lesson to understand a little bit about integers. First of all, you can always have like a nice textbooky definition, but in general, I just think of integers as all the numbers that we would put on a number line. So when I look at a number line, it's the number that I actually list. It's the 0. This is an integer. 1, 2, 3, 4, -1, -2, -3. These little half marks, I don't put a number on them because they are not integers. No fractions, no decimals, just positive and negative nice numbers. All right, so I just went through and I did a few of the practice problems, and that's what this video is really going to be, is going through the practice problems from your homework. So this type of a question says to mark each point by clicking on the corresponding number. To erase the dot, double click it. All right, so I'm just going to grab my mouse and I'm going to click on all of these points that are listed in this set. So that says click on 1. Okay, 1 is this dot right here. So I would click on 1. And 3. Oh, here's 3. And here's 5. And then here's 6. And that's all they want you to do, is pick out where those fall on that number line. Easy enough. All right, so then it pretty quickly gets into a little bit fancier stuff. So one of the things they talked about was absolute value. Now, the absolute value of a number is really just how far that value is, that number is, from 0. And so if you think of a number line, so we're going to think on a number line when we're doing these absolute value, and look at how far a number is from 0. Keeping in mind that distance is always a positive value, which means then that this distance, or this absolute value that I have here, will always be a positive number. Let's look at this first example. They want us to simplify the absolute value expression. Well, it says above, but I didn't want to click the whole screen, so here it was. This was the absolute value of a -4. That means we come over here and we look at this number line and we say, okay, here's -4. How many units, what is the distance to 0? So I would go 1 unit, 2 unit, 3 unit, 4 units. That is 4 units from 0. So the absolute value of the absolute value of -4 is a positive 4. Okay, let's do another one. What if the second one down here, it's the absolute value of 9? Well, I'm going to look at where 9 is on my number line. It's right here. And I want to count how many units that is from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9 units from 0. All right, so that makes sense. The number 9 would be 9 units from 0. The number -4 is 4 units. Does not matter if it's positive or negative. The absolute value of a number is always going to end up positive. I thought I'd do a little fancier one here because this one has a negative on it. But notice where the negative is. It's outside of the absolute value. This absolute value of 7. Now the absolute value of 7, that's how far is 7 from 0? Well, that would be 7. Positive 7. But then when you stick a negative out in front, that's going to flip it back to a negative. Sorry, that's my dog Shooter. He's listening, learning some algebra. All right, so you do the absolute value first, and then you attach the negative afterward because the negative is on the outside of that absolute value. All right, the next thing that this lesson gets into is what we call inequalities. Meaning things are not, sorry, my pen's not working very nice here today. I don't know what's going on. Can't read it very good. Meaning things are unequal. They are not equal. If they're not going to be equal, then that means they either have to be a less than value or they'd have to be greater than a value. That's this little notation right here. That means that, and that can be read, you can read this a couple different ways. 2 is less than 8. I think of that because the little part of this arrow is pointing at the 2, so the 2 is the little number. You could also read it backwards. 8 is greater than 2, and that's because 8 is on the big side. If you see like this little arrow thing, it's on the big side of the arrow, whereas the 2 is on the little side of the arrow. So that means 2 is going to be less than the 8, or reading backwards, 8 is greater than 2. Now we rarely read it backwards, but you need to recognize that whatever is on the big side of the arrow is the bigger number. What's on the small side is the smaller number. This would typically, just like we read books from left to right, we're going to read inequalities left to right. 2 is less than 8. Let's look at graphing these inequalities. The directions on this problem say graph the integers that satisfy the following condition. A is less than or equal to, that's what the little bar underneath means, or equal to. So it can be less than this value, or it might even equal this value. So I'm going to graph all the integers, that's what A is standing for, all the integers that are less than or equal to 5. I'm going to go to my number line and I'm going to start, well, it said it's less than, but since it said or equal to, I will go ahead and put a dot at 5. If it didn't say or equal to, I couldn't include that 5. And I want all the integers that are less than that. Okay, less than is always going to be towards the negative side of your number line. So I'm going to go everything towards the left. Less than is going to go to the left. And I'm going to put a dot on all of these integers. And it seems crazy, but that's what they want you to do, is just put a dot on every one of them. But it stops. Well, that doesn't mean that my integers stop. I could find more of them down there. So they want me to put this little negative ... which means that it's going to go, and I can't do this because this is not a live document, it's just a picture. So you're going to press this button right here, and it's going to go and show you that that goes to the end. All right, let's practice one more of those. This next one shows that we want all the integers, that's what the A is, all the integers that are greater than -3. Well, the numbers that are greater than -3 are going to go towards the positive end of my number line. Notice that this one does not say or equal to. So when I come over here and graph, I don't get to put a dot at -3 because it did not say or equal to. I just want all the integers that are greater than that. That means I would have to start at -2. And that's going to be the first integer that's greater than -3. And then -1 and 0 and 1 and 2 and 3, 4, 5, 6, 7. And I want it to continue on, so be sure to hit this little button right here and show that it would continue on to the right. That's how we are graphing integers on a number line. Now that's going to take us to the last type of problem, and I'm going to do several of these because this is probably the trickiest. And it says that, and these are going to be the inequalities, so you're going to see the less than or greater than, but you're also going to see the absolute value tied into that. To do these, we have to recall that the absolute value of A, as we mentioned earlier, is the distance from, I gotta write in cursive here, distance from 0. Alright, so I am looking for all the integers whose distance from 0 is greater than or equal to 3. The distance from 0 is greater than 3. Okay, so that means it's far away from 0. I want all the numbers that are far away from 0, or at least 3 units away from 0. So 3, because of the or equal to, I get to put a dot at 3. 3 is greater than or equal to 3 units from 0. So is 4, and 5, and 6, and 7. But that integer might have been negative, and so there are also negative numbers that are at least that far from 0. Negative 3 is greater than or equal to 3 units from 0. Negative 4 is. Negative 5, negative 6, negative 7. All of those are greater than or equal to 3 units from 0. I kind of think of it as I'm at 3 and I'm going to the right and to the left from there because I want all the far away numbers. Don't forget that you still have to put these dots in there to show at the end of your number line that you want to continue it. Okay, let's look at another one. This example says that we want all of the integers whose distance from 0, remember that's what absolute value means, the distance from 0 is greater than 5. Okay, all right, that's the far away numbers again. I want it far away from 0. Well, since it didn't say or equal to 5, I don't get to put a dot at 5, so I got to go to the next spot. So 6 is the first one I can plot, and 7, and everything to the right of that. But because a might have been negative, and I have numbers on the left side of my number line that are greater than 5 units away, then I have to put dots on this end too. And again, I can't use the negative 5 because it's not an or equal to. And then I would say all the numbers to the left of that. All right, this is our last one. And what's different on this one is now I'm looking for all the integers whose distance from 0 is less than or equal to 5. Well, if I want the distance from 0 to be less than 5, then I want numbers that are close in towards 5. Or I'm sorry, close in towards 0. Because of the or equal to, I would start with the 5. And then all the numbers that are closer to 0. So that's going to be the 4, and the 3, and the 2, and the 1. And it even includes the 0. But since a might be negative, it could also be negative 1 because the distance from negative 1 to 0 is less than 5. And so is this one, and this one, and this one. And because of the or equal to, even this one. But once I get beyond that, then my distance is greater than 5. So I don't want those. On a less than, you want all the numbers that are close to 0. In this example, then, I would have just these dots, and I would not be using the ... to show that it continues. It does not continue on past that. Okay, hope this helps you. Good luck.